Hello again, this is our third example on ray diagrams. And once again, you'll see from the examples that I'm saving myself a little bit of work by not changing too much about the problem. Our original example had an object out here, outside of the center of the mirror. In our second example, we moved our object into between the center and the focus of the mirror. Now we're going to move it in even further. Now we've got an object that's only 1 centimeter out from the mirror. And once we've got that object placed, we're going to draw our rays following our two big reflection rules, and we'll see what that tells us about the image that we get. So, reviewing, our radius is 6 centimeters. That means from the surface of the mirror is 1, 2, 3, 4, 5, 6 centimeters to the center of the mirror. Half of that radius is 3 centimeters, which means our focal length is 1, 2, 3. There's the focus right where it's supposed to be. Our object is still 2 centimeters high. Now it's supposed to be only 1 centimeter away from the mirror. So we're going to move this in right up close, and we'll see what that does to our image. The last image we got was magnified and inverted. We'll see if we get anything different this time. So the two rays that we're used to drawing are one that goes in parallel and comes out through the focus, one that goes in through the focus and comes out parallel. So, first ray comes in parallel, strikes the mirror right away at that point. From here, it has to go back out through the focus, which is easy enough. Project it back this way. And remember to extend your reflected rays in both directions, because we don't know if our image is going to resolve out on the real side or back in the virtual side of the mirror. Now, something a little funny happens when you do your second ray. You start from the top of the object, and you're supposed to draw a ray that goes through the focus. Well, that feels a little strange because the mirror is off to your right, and yet the focus is to your left. But remember that these rays extend in both directions. If you have to do a ray that comes from the focus into the mirror, you project that ray in a direction like this. That ray comes through the focus, it touches the top of the object like it's supposed to, and then it finally reaches the mirror at this point here. I didn't really need to draw that extra bit. In fact, I think I'll get rid of that just to keep the diagram from getting too cluttered. There. That's a little better. So, through the focus, past the top of the object, strikes the mirror here, and now that ray is supposed to bounce out parallel. So from that point, that ray extends parallel to the axis, and like all reflected rays, you extend it in both directions because we're not sure what our image is going to be like now. When you look for the intersection of the reflected rays, you find it right here. This is where the dark blue and the dark red cross. That is the top of our image. So, what kind of image did we get here? Our original object was 2 units high, centimeters, sorry. Our image is almost 3 units high, so our image, just like last time, is magnified. But this time, the image is right side up, or we call it upright, and for the first time in any of our examples, this image is actually behind the mirror where we're used to seeing reflections. This is what we call a virtual image. You couldn't put a screen to it. It appears to be in the space back behind the mirror's surface. There isn't really a space here. In most mirrors there's solid wall back in this area, but this is where your eye believes the image to be. It looks like the rays are coming from an object right here, 1 centimeter behind the mirror.